So under trigonometry today we're going to be looking at SOHCAHTOA. So SOHCAHTOA is the formula that is used for right-angled triangles. So it is the formula that is used for right-angled triangles. Take note of that. So we are looking at SOHCAHTOA. And in this SOHCAHTOA we can draw up three equations. So the first one, we have sine theta is equal to opposite over adjacent. Then the second one, we have cos theta is equal to opposite over adjacent. And the third one, we have tan theta is equal to this one, cos theta is equals to adjacent over hypotenuse. Then this one, we have tan theta is equal to opposite over adjacent. So these are the formulas that you use when calculating the angles or the sides of the right angled triangles. Let us now look at some calculations, and in these two calculations that I'm going to give you, we're going to calculate the angles. So we'll be calculating the angles. And the first example, if the triangle is in this form, and I have A, B, C, and I know that this is a right angled triangle. Then I have angle theta here. Then this side is 3 centimeters, and this side is 8 centimeters. And the question says I need to calculate angle theta, which is at A. So for me to find angle theta, I'm going to write my formula somewhere, which is SOHCAHTOA. And from this formula, I need to identify the sides. So I know that the angle that is the side that is opposite to the angle given inside, this is the opposite. Then the side that is opposite to the 90-degree angle, this is the hypotenuse, and the remaining side is the adjacent. And in this question have been given the opposite and the adjacent. So in this formula, which is SOHCAHTOA, I'm going to see which formula has the opposite and the adjacent. And from this formula is this one, which has sine theta. So I'll say sine theta is equal to opposite over adjacent. And I'll say sine theta is equal to, my opposite here is 3 centimeters, so I'm just going to write 3 divided by my hypotenuse here is 8, so I'm having 8. And for me to find theta here, I'll say theta is equal to sine inverse, so sine inverse of 3 over 8. And sine inverse of 3 over 8, I'm having 2.02 degrees if I round off to 2 decimal places. So that's how you can calculate the angle at theta. Let's take into another example. So another example, the triangle is in this form. And this triangle is a right angle triangle, and we have side A, side B, and side C. Side BC, I'm having 8.6, so this is 8.6 centimeters. Inside AB, that's 7.6 centimeters. And have been told to calculate the angle which is at point C. So angle theta, which is at point C. So the first thing that I'm going to do is to write my formula, which is SOHCAHTOA. And since I've written my formula, the next thing I need to identify the sides. So the side that is opposite to the angle that is given, this is the opposite. Then the side that is opposite to the 90-degree angle, this is the adjacent. Then the remaining side is the hypotenuse. And the formula that I need to use must contain the opposite and the adjacent. And the formula that I can use, considering the sign one, it has the opposite and the adjacent, so this means this one cannot apply. What about this one, which has the adjacent and the hypotenuse? Even this one won't apply, but the one that has tan is going to apply, since I'm having the opposite and the adjacent. So I'll say tan theta is equal to opposite over adjacent. So tan theta is equal to opposite, that's 7.6, so 7.6 over adjacent, that's 8.6. And for me to calculate angle theta, I'm going to say the angle theta is equal to tan inverse. So tan inverse of 7.6 over 8.6. And punching this on the calculator, it's giving me 41.45 degrees if I round off to 2 decimal places. So this is how you calculate the angles in a right angle triangle using SOHCAHTOA.